Greetings. In this little cameo, I want to develop a series expansion of a logarithm function. And the function to be expanded is log to base e of 1 plus x. I'm going to do it by two different ways. Method A, first of all, we'll write 1 plus x to the power y equal to e log to base e 1 plus x to the power y, which in turn is equal to e to the power y log to base e1 plus x. The first step, all I've done is first of all taken the log of the function and then taken the exponent of the log. So I've returned it to the original function. And in the second part, just used a property of logarithms. Okay, so what we're going to do next is expand each side. First, on the left-hand side, we expand that by using the binomial theorem. And that will then be 1 plus yx plus y minus 1 x squared over factorial 2 plus y minus 1 minus 2 x cubed over factorial 3, and so on and so on. The modulus of x has to be less than 1 for that expansion to be valid. And on the right-hand side, well, we just use the exponential series. So that will be 1 plus y log to base e 1 plus x plus y squared over factorial 2 log to base e 1 plus x whole squared, etc., etc. And what I'm going to do now is equate the coefficients of y. So the coefficients of y in the second expansion is simply log to base e 1 plus x, which is the one we're after. And on the binomial expansion, that will easily see by inspection, is x minus x squared over 2 plus x cubed over 3, and so on and so on. Okay, now to turn to method B, which I much prefer. And so I'll start off by writing the integral of dx over 1 plus x equals the integral of, and under the integrand there is simply the series expansion of 1 plus x. So of course, that will be valid only when the modulus of x is less than 1. Now that is a well-known expansion and easily remembered, so I hope that you are familiar with it. And that will be 1 minus x plus x squared minus x cubed plus x to the fourth minus x to the fifth, and so on and so on and so on. And then all we have to do is work out the integrals. Well, the left-hand side will be 1 plus x. The right-hand side will be x minus x squared over 2 plus x cubed over 3 minus x to the fourth over 4 plus x to the fifth over 5, and so on and so on and so on. So there we have our series. Now, a third line is to use Maclaurin's theorem, which requires a bit more labor than B, and as mathematicians are not renowned for their zest for hard work, I've left that for another time. Okay, so in the meantime, thanks very much for listening.